So far, we saw some of the technologies that are used in additive manufacturing for machinery, and we saw some examples here. But of course, even though if you have the knowledge for 3D printing and know how to design parts, still there is this kind of an obstacle of how to choose the right part for additive manufacturing in machinery.
Yeah, there are a lot of mechanical designers and engineers.
Yeah.
So you guys need to understand the technology enough. So at the beginning of the design process, you can make the right judgment. Am I going to mill this? Am I going to sheet metal this? Am I going to print this? I think that's important for you to keep in mind when looking at this.
Yeah. And yeah, machines like this, for example, what you see on the slide right now, what might be a bit overwhelming for choosing one part that could be right for additive manufacturing. And I must say that it is sometimes, and maybe through experience, through trying and using it, at the end you gain the experience and the confidence to know which part are the right ones. However, to make it easier for you, from our experience, we summed up here several points, and they are on the base of the aim you want to achieve by using additive manufacturing. So if the aims are considering product cost reduction or product improvement or spare parts stock reduction, there are different points that you focus on to choose the right part. So, for example, for product cost reduction, there is the focus points of choosing complex CNC machine parts, like the tool holder that we presented before. So it's quite complex part. It needs a lot of machining. It needs also several parts that are with quite tight tolerances. So that makes it complicated. Then that is an assembly, but also there was the gripper example that it is an assembly. So we also look at these assemblies that are not with large dimensions, so more or less small to medium size parts. And then we look at as I mentioned, small to medium, but also small parts that don't need to be an assembly, but they have bigger functionalities, and it's possible also to make optimization regarding the material. Then I want to emphasize this last point, which is metal to plastic conversion, because we've seen from our experience that many engineers are using metal like aluminum because of the convenience in CNC machining for using it. However, in many cases, as it was in the example for this motor holder here, it is really not necessary to use metal. So simply moving it to plastic and 3D printing it and ensuring that it's going to be strong enough, we were able to transfer its functionality and its production method from CNC machining to 3D printing. What you see there on the photo is topologically optimized form, which would work more or less the same like the original one. To go to the next aim, which is product improvement. So that is one of the aims we when choosing part for additive manufacturing, besides cost reduction. This is an example for customization. I know that maybe in your environment you're not using customization as much, but anyway, I want to show you this interesting example from Gerhard Schubert and Ultimaker done together. So it's a tool for holding products in packaging industry. So it's a tool that can hold different types of holder, but it can also be customized for specific product. So from the original part that you see on the top, it was redesigned to the one on the bottom. It makes it easier for it improves the functionality and improves the product because it can be customized by the needs of that specific product, which is in this case the chocolate Santa Claus. Then another topic is the weight reduction, another focus point. A weight reduction that could be interesting for you, maybe for some parts. it's when you reduce the material, and in that case you reduce the weight. We saw in the example of the tool holder that by reducing the weight, there were also some other improvements in the whole module of the machine, like at the end we were able to use a piston that was smaller and cheaper. Here we have an antenna bracket for satellite, so it's totally optimized structure with probably used with the software for topological optimization and generative design. And then on the bottom we have an example of hydraulic block. The total weight when CNC machined used to be 30 kilograms. When optimized, it was reduced to around 6 kilograms, and you can see how much optimized it is in the pictures. And another focus point for product improvement is integration of multiple parts. So we also, some of the examples included this point, but I want to show you a different example here, which is this product gripper again, which uses multiple channels for the air, so it can create a small vacuum that would grip products. The original part produced with several sheet metal parts and a lot of tubing there for the vacuum was integrated into one part, the black part that you see on the picture. So all the internal channels are inside because you can make such a complexity of a part that the internal channels are going to be included, and then it will be printed in one go. So in one print you will have all that, but those vacuum cups, those are not included, those are standard products. However, it's an integration of multiple parts which improves at the end the product itself. And at the end, I know there are very few people here from stock for spare parts, but additive manufacturing can also reduce the necessity of spare parts. One example is a Siemens Mobility, which is Siemens Mobility is the company that maintains the transport system in Germany. So they have their stock almost all digitalized, and they have 3D printing supply network, which can produce their parts in a matter of days. So they have their parts saved whenever needed. They print it like the handles in the trains on the picture on the slide. Besides the stock that they use, the parts for the stock that they use for 3D printing, they also use 3D printing, of course, for producing different tools in their factory. So that is the example on the picture in the corner below. And there is this other example, which is this interesting valve for beverage in filling industry. Packaging, and this is again an assembly integration of several parts made into one metal part, but I don't want to focus here so much on the function, but of the advantage that there is no need for printing these parts to have in stock, but also only printing it when necessary. So no stock and no assembling time for this part is necessary. These were some of the aims and the focus points that we usually use in our experience with Defined, having the knowledge and knowing how to choose the right parts for 3D printing, you can maybe finally take the step and use some of that knowledge for making end-use parts for 3D printing.
Yeah, that was what we wanted to show from the slides. I hope it became clear that not only with the right knowledge, but also with the right mindset, 3D printing can really make a difference. But you really need to think about the full chain, also towards validation to ensure good quality and to make sure that your manufacturers are up to speed. We set up because we have a good collaboration with the Knowledge Sharing Center, but also with ASML, we created a separate email box. So in case you do have any questions, feel free to shoot your questions there. We're happy to support on the full process. And I think for now, I'm going to give this one to you, Even.
Yeah, there's no slide anymore, but
someone new will appear again.
Okay.